In this video, we will see one more form of a complex number called the exponential form. And that exponential form is r e to the j theta. And you'll see that we've got the same value r, which is, in a sense, it's what they call modulus or magnitude, like it is in vector. So modulus. And then we have E, which is Euler's number, approximately 2.718281828, and so on. And then we have in the exponent on E, J, which indicates it is a complex number. And then theta, which is the angle of rotation from the positive x-axis. The one specific thing about this theta is it must be in radians. Okay, so that exponent angle, you must convert it to radians. And really, that's the only difference between our polar form and our exponential form, except for the e and the exponent, is that we have to change the angle into radians. So let's just do an example here. Where we are going to express the number in polar form. Notice this is polar form, and I want you to be able to recognize them. This is r at an angle of theta. And we're going to express it in exponential form. So the exponential form is r times e to the theta j, or j theta, whatever order you want to put it in. But r is going to be the same r. So we've got our r at 9.5. There's nothing to change there. But theta is 140 degrees. And we must express theta in radians. So we just have to multiply by pi over 180 and convert it into radians. So that'll be 140 degrees times pi over 180 degrees. With the calculator, 140 pi divided by 180. And just write that as a decimal to maybe 3 decimal places is going to be fine. So that's 2.443 radians. So expressing 9.5 at an angle of 140 degrees, which is polar form, this is equivalent to 9.5 e to the 2.443 j. Now it's in exponential form. Here's an example of a number in rectangular form. We are going to put it in exponential form. So this takes us a few steps further, because in a rectangular form we have x plus yj. But we're going to have to calculate r, and we're going to have to calculate theta. And specifically for the exponential form, we're going to have to make sure that theta is in radians. So I'm just going to draw this just so that we get the angle right. Remember that it all depends what quadrant it's in when we adjust the angle. So let's see where 5.2 in the x, maybe about here, I'll call 5.2, as long as we go positive, right? And negative 8.3 in the j, well, let's put that down here. So our 5.2 minus 8.3j sits down here. If I want to attach that to draw the hypotenuse, we'll have to calculate the r, which is there, and I would like the rotation from the positive x-axis counterclockwise around to there. So let's begin. R, well, we know that r is equal to the square root of x squared plus y squared, right? So the square root of 5.2 squared plus 8.3 squared. Just as a side note, I think I've mentioned this before, even though it's a negative 8.3, we're squaring it, so it'll turn positive. So I'm just ignoring the negative at this point, but that's not because it's not important down here to show the direction. All right. Okay, so let's see what this number becomes with the calculator. Square root 5.2 squared plus 8.3 squared. And let's go one decimal place just like those. So it comes 9.794. So let's just call it 9.8 for now. And then theta. Well, theta is the tan inverse of y over x, which is tan inverse of minus 8.3 over 5.2. And throw that in the calculator. Inverse tan of minus 8.3 over 5.2. I'm getting a reference angle. Well, it's coming out negative 57.9. Let's say negative 58 just to go whole number. And that makes sense that it's negative because this is showing me that this is 58 degrees in here. That's the reference angle, okay? All right, so from a positive angle rotation perspective, this will be 360 minus 58 degrees, which is 302 degrees. Now, I want that in exponential form, which means we better change that to radians. So this is also 302 degrees times pi over 180. Okay, so 302 times pi divided by 180. And I get 5.27 radians. 271, let's go, because it's 5.27089, 5.271. All right, so therefore, we have found that 5.2 minus 8.3j is, in exponential form, 9.8 is the r, e to the 5.271j. Here's another example. In fact, we could use this as a practice for yourself. Express the complex number in exponential form. It's already in exponential form. Express it given in exponential form, in polar form and rectangular form, okay? So you're going to change it to r angle theta, and you're going to change it to x plus yj. If you think you can do that, pause the video and start that now. Come back and check your answers with mine after you are finished giving it a try. Okay, so polar form. I'm going to go like this. We've got our r, which is 4.5, and our theta, which is 2.3 radians. We could just leave it in radians and say, all right, that is 4.5 at an angle of 2.3 rads. That has been done. Now, we've been used to putting our angles in degrees, though. So let's just go one step further. We'll take our 2.3 rads. In order to convert that back to degrees, we multiply by 180 over pi. So this will become 2.3 times 180 divided by pi, and I'm getting 131.78. So 130, let's go 132 just to go nearest degree. So this could be 4.5 at an angle of 132 degrees. Now what quadrant is that 132 in? 132 degrees is quadrant 2, right? So let's just watch for that when we do the rectangular form. Quadrant 2 should have negative x, positive y. So let's do that now. If I want to be much more specific, I'll use the 131.78 degrees, just so that we get our x and y a little more precise, okay? So for rectangular form, x equals r cos theta, y equals r sine theta. So the x is 4.5 cosine, and let's just use this more precise angle, 131.78. So that'll be 4.5 cos 131.78 minus 2.998, roughly minus 3, okay? And y is going to be 4.5 sine 131.78. 4.5 sine 131.78. And I'm getting 3.356. So the rectangular form is minus 2. We'll just say minus 3. Minus 3 plus 3.356J. Okay, so we've got a rectangular form here, and we have a polar form here. All right, we'll take a look at one more example here, and that is, let's see, express the power of a complex number in polar form and rectangular forms. So recognize what form we have. We have the exponential form inside the brackets there, and it's raised to the power of 2. So I wanted to show you this one just because first we want to know the exponent 2 must be applied to the r and to the e exponent. Okay, so think about your laws of exponents. 3.9 squared, and then when you have a power raised to another power, you multiply the exponents. So this is e to the power of 2 times 1.2j, which becomes 15.21 e to the 2.4j. All right, so we must apply that exponent before we start changing into the other forms at this stage. Well, it makes a lot more sense to do that power 2 first. All right, so now there's the one that we want to convert to polar and rectangular. What I would suggest now is you practice that, come back and check the answer with mine when you finish. Okay, so polar, r angle theta, and rectangular, x plus yj. So pause the video, give that a try, check your answers when you are finished. Okay, there are the answers. You will see that the polar form became 15.21, the same r as 3.9 squared, at an angle of, I rounded to 138 degrees. However, I'm going to use the decimal form when I convert into rectangular form, just to be slightly more precise. It might not make much difference, but let's see what happens here. So x is r cos theta. I get minus 11.21 for the x, and y is r sine theta, so 10.28 for the y. So make sure you put it in rectangular form, x plus yj, and there we have it. So a summary down here of the forms that you have seen. Here you are. Take note, those are the forms of a complex number that we will be working with. If you want to jot those down or take a snapshot of it, then there they are, and thanks for watching.